Okay, I'm going to pick up where I left off last time, and we're going to do this in SolidWorks now. Let's see. And so I'm remotely controlled to my, linked to my computer back up at the University of Hartford. So it's kind of sad we don't get to see it. So I made this 4-bar and put into the configuration where the crank was at 90 degrees. That's because that's how I arranged it in the Excel, right? I started with the crank at 0 degrees, so it'd be nice to start at the same place. Then I don't have to shift the data later on. And I did that by putting in one of the a mate at the end where I made these two things coincident to each other. The two faces over there coincident to each other. So I'm going to create a motion study. You could see that I already made one previously, but we'll start from scratch. And I want to make this a motion analysis. So you need that motion analysis tool to be able to do all of these things. And I think we used it a little bit in early part of the semester in class. All right, so we have the orient. I'm going to disable this playback of view keys type of thing because it just messes with us. Now we're gonna have to put in some parameters right in here. Well, I guess I'll do this first. I go down and I open up my mates. And I'm going to go ahead and suppress this mate here. It doesn't suppress it back in the model, but it'll allow this thing to move. Now we want to put a motor onto this piece. Do I want to do? Yeah. So I put the motor on here, and I'm just going to click onto it. And it wants to know it in RPM, but we have 25 radians per second, so we want to turn that into our RPM. So coming back here, I'll just use this as my place to draw this out, and I'm drawing while the laptop, the screen is up, so my handwriting is going to be terrible. But we have 25 radians per second, and so we want to multiply by 60, right? It's going to have seconds per minute, and divide by 2 pi, so that's going to be radians per rev, and so we're going to end up with 238.7 RPM. So I come back over to here, and I actually want to double check on something. All right, so when I'm back over here, I'll put this. No, let me double check now. I only have 4 sig figs there, but I've got to wonder if I went and I calculated this and I made a lot more sig figs. That it's going to help me, I think, maybe. So if I multiply that by 60 and divide by 2, divide by pi, I end up with, all right, so I might want to, so I have a very accurate comparison, I might actually want to write that down. So I think, well, let me actually, I'm going to copy this, paste it over here. So I'm very lazy. So I'm going to paste the value right here. So now I have that value. I can copy that right there, and it should be able, when I go back over into here, be able to stick that in with a boom right there. Okay, so that's going to be, I got a lot of sig figs going on here, so I think that's going to help me out. So I put the motor in there. I need to scroll back up to there, and I can see that little key, but I only need 3 rotations. I don't actually want more than 3 rotations. So I will come in here and I will figure out what time is needed for that, for 3 revolutions. So I say that 3 revs right here divided by let's see, 25 radians per second. It would have been easier if I got myself revolutions per second up above, but I could do this in any way that I wanted to, but I decided to do it this way. It's a little weird here, 2 pi right there, and that's going to be radians per rev right here. And what I'm going to end up with is that needs to be 0.754 seconds. I think there's some more decimal places over there. So I want 0.754 will be good enough for me. So I want to move this so that it only goes that far. So, but it's going to be hard to read here, so I can go ahead and zoom in. And I could get closer and closer. It doesn't really matter. There's 7.5. Let's go. There's 7.6. There's 7.55. That's going to be good enough. It's actually even a little silly to be going there. We just don't want more. We don't want more data than we have. Okay. So now here's the important thing. We want to try to get our time steps to match up. Now that's kind of a little difficult. Right, so we go into that little gear right here, and we get these properties. Actually, before I even start, let's go ahead and solve it the way it is now. So we go ahead and we go over to this little calculate button right here, and it solves for the thing. And I have the playback set at 0.1, so we could take a look. And it's a little herky-jerky because that's only 25 frames per second. And we aren't even solving for 1 second. Like we're only 0.75 of a second. Let's take a look and see what the results are going to be. So first I'll put on the coupler curve by taking displacement and trace path right here, and we'll pick out that little point right here. Let's see if is he going to let me do it? There you go. Yeah, that's not a very good coupler curve, is it? We could also hit this results plot thing again and go for velocity. And now there's a little quirk that happens here. We'll see here in a second. We have velocity, linear velocity. I pick from the second and the third rolled out. I'm going to go to the X component, and I'm going to pick out that little point at the top. I'm going to create a new plot. Boom. Not very good. Not a very good looking plot. Let's also add in. Let's add in Y, because that's actually Y looks a little bit more interesting. I don't think well. I guess it would be good to take a look at this. Anyway, we want to find the velocity, and now let's get the Y component. All right. So here's going to be the quirk. For whatever reason, the first time I do this, it always seems to give me the wrong results. Whoops. All right, so that's actually the correct results, but I wanted them on top of each other right here. So this is going to be easier for me. So let me just delete this down here. And what I want to do, let me do it over again. I meant to do this, put them on the same graph. It's going to make it just one step easier later on. But so that actually did give me the correct result. So I made a liar out of me. Let me go to this. Sometimes it's hard for me to grab a hold of that stupid point right there. A lot of times I will make a sketch on top of this piece here and then put a point in there. It likes to grab the points more than the vertices. And sometimes, yeah, I gotta like get it over from the side. Boom. All right, let me do that. Now what I wanted to do is I wanted to add it to an existing plot. And I think it's plot 10 I want to add it to. Oh, Banggood is sending me an email. I'm going to get it turned on email notices off. Yeah, here's the weird thing. Okay, look at that. Now, it won't give me a common scale. It rescaled the thing. But if you look at these numbers right here, you can barely see. It's very, very small. That says 0.5. That's not true. So what I end up having to do, I go down to this results. And it's this guy right here, and I think I gotta go to here and I edit the feature, and all I did was I just pulled these things down again and looked at them and said okay, and sure enough, look at that, it made it 482. So the range, this is actually in the correct range for it. I don't know why that does that. Okay. SolidWorks, great. So anyway, this is a terrible graph right here, right? This isn't good enough for us. I think is it this one that I move the thing over? Yeah, I gotta hold down Control and then I do the arrow to shift the thing over. So let me fix this. I want to make this a better resolution here. I need more time steps. So I go to that gear thing right here, and I got to adjust this. Now, I made a mistake before thinking that I could only have integer frames per second, but it turns out it let me put any damn thing I wanted in there. So what I'm going to do is I'm going to calculate as best that I possibly can, because this will be, it'll really change things up. I want to get what the time step has to, well, I could calculate what the time steps are already, right? So I did that over here. This was something I did earlier, where I wanted to find out. So I just found out what the time steps currently are in Excel. And that comes out to 3.49 change e to the minus 3. And if I took 1 over that right there, it becomes the number of times, the number of steps per second that is needed to grab that time step, right? Writing it out another way, I could just as easily have said, okay, well, I have 5 divided by 360, all right, so that's what a proportion is, and then I could take times 2 pi and divided by 25, and I'm going to get the same thing. I'm going to get that 3.4906, blah, 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 e to the minus 3, and then I could take 1 over it, that, and end up getting my time step. So just like I did before here, like to see how many we could possibly get, I'm going to hit Control C and then just right next to it. And by the way, I probably will delete this later, but I'll grab that time step right there. So that's going to 286. I had 280. I tried 286 and 287. I was trying to this. I believe this will work out a lot better. So I come back into here and paste that in, and let's see what happens. Wow! Oh, what a much smoother looking coupler curve. And this comes out really nice too. By the way, this is just a side note, not necessary, but if you want to make these things so they look like the other graph, you'd probably want to come in here, and I think in like in Excel, the default, they decided that it was something like this right here, 1,000, and then this one was 500. And this one was like 100. And then I have to do it again for the other graph right here. So I got to go to that graph and grab his axis properties and do pretty much the same thing. Minus 1,500 and 3,000, just so that you can see apples to apples comparison. So if you wanted to use their graph instead of making it in Excel. But this doesn't really have any effect. It just changes the appearance of this this one right here. But we want to get this data. We want to use the data so that we could grab it. We could compare it, and it's easiest to do that within Excel. So I'm going to right-click on this, and I'm going to hit export to spreadsheet. I'm saying the word export. Export. Doesn't it sound right? Anyway, it pops it up open. It opens itself up over here, and they show a graph, and I can't stand graphs of things that have these little the markers in there. Get rid of the markers. But what we have here, and we can actually take a look at the first time thing. Check it out. That is what we ended up as a time step. I just want to look and see comparison wise. Stick that right in there. Have them side by side and take a look. Yeah, we didn't get exact. It's interesting. We didn't do. It isn't perfect there, right? So it's not going to line up perfectly. It's going to be off. You could see. It's interesting. So maybe it forced it. Let me double check something. I want to look at my time steps in here. Did it automatically? Yep, it did. Right there it is. It only would accept an integer. I was wrong. So we are always, when making our comparison, we're going to have to take that into account. We're going to have to say, oh, well, it's as good as we could do. We could try for 287. So I was correct before. It's interesting. So that's the best we can do. So whatever, we'll just go ahead and make that comparison. We'll grab a hold of these values out of that exported. Let's see, there's 217 of these. I guess it makes sense. It makes sense that it had to be an integer, but oh well. And I can put that over to here, right? So I could, by the way, I'll move this guy out of the way, and I think it's got to go right here, right? And let me format column width. I can also, well, I'd probably I'll change with the number formatting just so they look similar to each other. There's the numbers and the number of decimal places. Well, actually I have the time right here too, but I'll just leave them like this right here. There you go. Okay, so if we come down here, we could see at this is close to being the right time, and that's not too bad right there. To check it out, right? So this was the velocity in the x direction was 1,000 right here. So this is what our SolidWorks thing is going to be, but it's going to be the time. It's going to get worse later on, by the way. As later on, I mean, as time marches through, because the time steps aren't the same, it's going to get. It's not going to be great. So anyway, I'm going to go and paste this as a picture. So I just put these up next to each other so I can check them out right there. So we're darn close. But it's the time steps that's really messing us up here as part of this. And we could, of course, graph these things, and we probably should graph them at another time. But I'll just also, if we're going to put them inside our Excel, we should label what they are. So this is SolidWorks right here. On top there, just to remind ourselves what it is that we have inside here, right? There's a lot of data. We want to try to manage it and keep track of what all of these things that are taking place are. And I think that's all I need to do for this video right here. Otherwise, it's going to be way too long. And that's what I did with the other videos. I made them way too long. I showed you things you didn't need to know, and why bother, right? So we could add that to the graph right here if we wanted to. The thing is, it's really tough to see to make. They are so close to each other. It's very difficult to tell one apart. So with that, we have a 17-minute video. Hopefully, this is useful stuff to you. And let's see what we're going to do for this one. Let's see, we'll add something. This is value added. Here's a picture of me. Ta-da. I think I don't think I've shown base. See, I'm running a number of classes, and in those some of those classes, I've been showing off various guitars and things. But so here is my Music Man bass right here, but it's not really a Music Man. It's a knockoff, so I put gaffer's tape over it. But it's a nice. I like this bass. I like this configuration here with the single humbucking bridge pickup. It's got some active electronics in it, and it's got a nice tone. I mean, I'm not a bass aficionado. I might play bass in another band at some point. I like playing bass. It's like it's kind of fun. You're like buddies with the drummer, and you're in the rhythm section, and everybody makes fun of bassists. And I like slapping and popping a little bit, but I'm not very good at it. But here is like one of the only slap and pop in bass lines I know is Higher Ground. Not the Stevie Wonder, but the Red Hot Chili Peppers version. race. How low can you go?